All right, Mr. Captain J. You asking me a question about, sir, the bias is on the emitter of the output power transistors. I put the positive probe on the negative probe. What? And oh, sorry about that, guy. And then the negative probe, I will put it. No, you don't put the ground. I mean the negative probe, the ground. You don't place that on ground. So I mean the negative of the multimeter, because that's not the way you adjust the bias. That's only to see the offset of the audio amplifier. I can explain that later because that's the offset. That's another subject. So today we're talking about the bias. That is really important. The bias. Okay. Today I'm gonna take the time to explain you a lot better, so you can understand what is the bias on this amplifier. Most of the Class AB audio amplifier you will adjust it this way. Okay, so let me explain it. This is the layout of the Yamaha P2200 that Mr. Willie B. Serna built. He designed the layout. I just need to clarify that I did not make this layout. This was made by Mr. Willie B. Serna. So I just need to clarify that. All right. The bias, you will measure one resistor. You only need to measure only one resistor. You don't need to measure all of them. Only one resistor. You can measure this one here, R143. This is the positive area of the amplifier. As you can see, this will have the voltage, the positive voltage of the audio amplifier. So you will measure this one here, this emitter resistor. I'm going to place on like a probe. Let me see if I have those, because I don't think so. But anyway, don't worry about that. So you will place a let me make some dots so you can see what I'm talking about. So let me place the dot. All right, there you go. So let me turn this into black. All right, there you go. So you will place the multimeter. The polarity of the multimeter does not matter as long as you have a millivolts. That's the only thing that matters. It can be negative or positive. It does not matter. You only reading the voltage drop on one single resistor, just to adjust. Sorry about that. Just to adjust the bias. And it's kind of early today, so that's why. So that's why I gotta make the video, so to make sure that you don't make a mistake, because it's kind of expensive if you make a mistake on the circuit. So it sucks when you have a power transistor that blow up because you have a wrong bias adjustment. It's kind of sad. So that's why I gotta make this video. That happened to me with the Honey Badger. I blow up all the power transistor, but actually the bias was adjusted correctly. The only thing that happened is that I didn't have a correct heatsink. The heatsink that I was using was too small, so I blow up the Honey Badger. But all right, so this, as you can see, you can place the positive here. It does not matter. You can place the positive here on this emitter resistor, positive here, and the negative here, as you can see, and then you will start to read voltage there, millivolts. One sample. You can adjust it from, let me sorry about my throat is it's kind of early today, from 15 millivolts up to, let's say, 23 millivolts. Let's go with 23 millivolts, 20 millivolts. So it does not need to be perfect. 22. Let me see. I want to increase the size of this phone. You can see, oh, it's too big. Anyway, just so you can see. All right, there you go. It's too big. All right, it's okay. So that's the voltage that you will read from this emitter resistor. You can read from this one here, R143. So you can measure the bias. I have the simulation of the amplifier. Okay, here's where you're gonna place the trim pot. You say that you're gonna install the 1K. Actually, you can install 1K fixed resistor just to test out the amplifier, but you're not gonna be able to adjust it if you have a fixed resistor. So you need to have a variable potentiometer or resistor. the trim pot. Sorry about that, trim pot. So you can you be able to adjust the bias. Make sure, sorry, make sure all these power transistors, the power transistor on the driver and the bias transistor, they should be insulated with the mica and some thermal compound onto the heatsink. Right now I just draw sort of like a rectangle. It will represent the heatsink. This is the heatsink. Inside this line there is a heatsink. This is just a representation of the heatsink. Actually, this talking about the supply, something else. The supply voltage for this amplifier, you can actually use a less voltage. You can start with 50 volts, maybe 60, 65, 75. I already tried on the simulation yesterday. I was doing some simulations with the lower voltage. As you can see, the supply voltage is 50 volts, so you can start it with 50 volts just to test out the amplifier, and then you can increase later on. You can increase the voltage. One sample 65 volts, 75, up to 80 volts. Sorry, wait. I gotta drink some water. Gotta leave. Oh my goodness. Still, it's kind of early. That's why it's 9:36 a.m. in Puerto Rico. So I was doing some adjustment and I came out with this number. The bias adjustment for this is 850 ohms. So here you install 1K. Let's do that. I'm going to change the number here to 1K. Let me see, just to see if there is a difference. All right, let's see. I'm going to adjust this to 1K. All right, let's see. I'm going to adjust this. What is the? Oh, there you go. It's down there. It's down there. Going to adjust it. Okay, gotta increase. All right, that's too much. I just need to know. Okay, there you go. Okay, 1.2K. Okay, 1.2K. Let's continue. Okay. I just need to know what will happen if you just install 1K resistor there. Okay, there you go. 1K. Let me see. I gotta. Okay. I'm getting close. Okay, let me see. Oh. 99, 99.9, 999 ohms. 1K. Okay, 1K. We got 1K here. Sorry about my throat. Oh shit. That's why I don't like to make videos when after I have breakfast, because you know when you have breakfast you have something in your throat, like you cannot talk. You'll be like coughing because you have the grease from the eggs and stuff like that. So all right, so here so I know that it's 1K. The percent is 55.6%. I'm going to change that. Oh, that's why I don't like to make videos like this. Okay, let's see. It's 50. Okay, I'm getting close. What's the last number? Let me see. 55.6%. Okay. There you go. Okay, so now we have 1K. Sort of like I'm simulating that like we have 1K resistor there instead of the trim pad. But I recommend you to have the trim pad there so you'll be able to adjust the bias. You can see here. Oh my god. Okay. This is R143. I gotta look for R143. Okay, it's this one here. So let's do that just to avoid confusion. I'm gonna remove this this meter here. Okay, let me see. Okay. Okay. Oh, okay. It's on simulation. Sorry about that. It's on simulation. I'm gonna place the meter here. The multimeter. Like I said, it does not matter the orientation of the multimeter, as long as you have the voltage on millivolts, it should be fine. So it does not matter the polarity. As you can see, I placed it reading. God damn it. Okay, sorry about that, guys. Just my throat, it's not behaving correctly. God damn it. That throat. All right, let's go. So this is R143, and this is the resistor that you're gonna measure. I call it the voltage drop. So you're gonna put in any position, does not matter. Like I say, the polarity does not matter. As long as you measure the voltage on these resistors, so you can read the bias. So let's see how much bias we can get with 50 volts on the supply voltage and the bias trim pad as a fixed resistor. What is it? What is it? Okay, okay, so as you can see, we change the value of this VR101. That's the bias variable resistor. So we're gonna see how it's gonna behave with 1K fixed resistor. So this, let me write it down here. This case, it's gonna be 1K fixed resistor. Not recommended, but I mean, you don't have it. You don't have a trim pad, you can just try this. So this is going to turn into one fixed resistor. All right, let's see how much bias we can get. I gotta disconnect the input of this design. The output speaker, I need to disable this connection 1 and 2. Okay, I disabled the connection. Now we're gonna see how much bias we can get with the 1K fixed resistor. I'm gonna turn on the simulation to see how much bias we can get. It's kind of low bias, as you can see. Start really slow. All right. You got 14 point. It's increasing the bias slowly, but we got 16. Okay, 16, 17 millivolts, millivolts. All right. Let's see, 18.3, 19 point. Okay, I see. At least like a 21, 23 millivolts. Let's see if still increasing the bias. $21.2. That's weird because I changed it to 1K and the bias is about the same. Okay, you gotta wait until the simulation completes the voltage reading of this emitter resistor. Okay, let's wait a little bit more. All right, I see 22. Okay. I was reading in the book about the bias adjustment. I think it's J. Randy Sloan. That book, he mentioned something like if you don't have a tool like instrument, so you can check the THD, the total harmonic distortion. You can actually adjust it to about 47 millivolts, but you have to measure two emitter resistor instead of one. So that will be the half of of that value. So instead of, okay, you will do this 47 divided by 2, you will have about 23.5 millivolts of bias adjustment. So right now we are getting really close to 22.152. It's kind of like a stop right now. It's going really slow. You just gotta wait a little bit more, just to make sure that does not surpass that value, or maybe 24 millivolts. It should be fine. I don't think it's gonna be a big deal, as long as you have a really large heatsink on your design. So right now we have 22.157. I think that should be fine. It's good. So it's good now. So we can stop the simulation, and I'm going to show you how it's going to behave. Now I'm going to enable the output, the low. This should be the 4 ohms low, represent the speaker. And now we're gonna place the input sine wave, just to see how it's gonna behave. Okay, let me save it just in case, because sometimes my computer crash. I mean, not the computer, I'm talking about the software. Sometimes the software crash. So we're gonna see how much power we can get from this design. This window here is distortion analyzer XDA1, and this one is the watt meter, just to measure the power in watts. And we have here the oscilloscope, just to see the sine wave, how it's gonna look like. Let's turn on the simulation just to see. Okay, I see something that is not okay. So it's under bias. I see a little problem here. Yeah, because okay, I think because I changed the value of that resistor, it's kind of like a fighting. You need to have a little bit more bias. So right now it's acting normally. Oh, there you go. Because I noticed on this design that the bias is kind of slow. I noticed that on this design. Right now it's a normal operation. As you can see, we have here, okay, distortion is kind of high. It's a little high because right now it's in 257 watts of power right now to 4 ohms low. You're not gonna be able to see it. Let me see if I can place the watt meter here on this and increase the size of this thing. Let me see, appearance, so you guys can see the power in watts of this design. There you go. That's what I'm talking about. All right, let's see. This is the watt meter, and it's measuring the power in watts. The dissipation of that low, the 4 ohms low, is 258 watts of power right now to 4 ohms low. That's pretty good right there. That's pretty good. and then the distortion is a little high. Is 0.010%. It's a little high because we actually testing the maximum power output before clipping. So without clipping, I really don't want to see the clipping. Okay, so let me put this window here so you guys can see 257. Okay, 257 watts. I'm going to increase the power to see where is the clipping. Where is going to stop the clipping? Clipping basically is a distortion. We want to see. I'm going to increase the amplitude, the input amplitude. Sorry about that. There you go. I should drink like a lemon juice before I make these videos, so I don't have that oil in my throat. Man. Okay. Okay, there you go. We have clipping right now. We have clipping there, as you can see on the top. Okay, so I gotta lower the input before so the clipping disappear. About sorry. Oh, that's bad. That's bad. About 260 something watts. I would say 260 watt. Okay, let's see how low the distortion can go. One example, I need to know how low this amplifier can go on distortion. So let's change the amplitude, the input, to a 100 millivolt just to see how low the THD is. So let's wait for the simulation to stabilize. Let's see, we had 5 watts of output. I just need to see distortion. To see lower distortion. That's what I'm trying to say. All right, there you go. Okay, we have 0.012. It's a little high because I lower the bias. The bias is not the. It's weird. Okay, guys. I see. I think this amplifier takes time to stabilize. I see the 0.009, 0.08. Okay, 0.9, 0.10. Okay, it's good. I believe it's good. So let's lower this number, the amplitude. Let's go with 50. Okay, 50. Let me delete this. Oh no, I cannot delete it now. Okay, let's see. All right, we had 1 watt. Okay, I just lowered the amplitude, the sine wave. Okay, 0.011. Let me see. 11. 10. Okay, it's 10, 12. See, okay, 9. 0.009. I believe it's good. So remember, like I always say, this is just a simulation. I don't think it's gonna give you 100% result. It might be different on the real time, so it's gonna be different. So as we see, a 1K fixed resistor can be used here, but the trim pad is necessary so you can make a fine adjustment of the bias. So one more time, this is the resistor that you're gonna measure the bias. Here you will place the multimeter on both sides of the leads of this resistor and begin doing adjustment if you have the trim pad. If you don't have the trim pad, you cannot do any adjustment. So it's just gonna work. It's just gonna work. A fixed resistor. And do not forget to place the 13 volt AC that goes connected here, as Mr. Willie told me that he did not use it and it was working fine. So anyway, I will use it. I gotta ask him again one more time to see if he's using this 13 volt AC, the separate supply voltage for this input here. And yeah, that's it. I hope you guys understand the way you adjust the bias on this particular design, so you don't make mistakes. You don't do bias adjustment placing the meter on the output and then the other one to the ground. No, that is not the way you do bias adjustment. The bias adjustment is always reading from the one of the emitter resistor. In most of the class AV audio amplifier, you will do that. So in some other designs, it's gonna be a different story, but you never do that. The only way when you measure that way is only to see the crossover distortion, the offset. Sorry about that. The offset. That's the only way you do that. So you place the multimeter here, the positive, and the other one here on the negative. What you do right now is measuring the offset of the audio. The offset can be from 10 millivolt up to, I think it's 20 millivolts. That's the offset. So you need to read about that. So that's really important. So always use the emitter resistor to do the bias adjustment. All right, guys, I'm gonna cut the video. Sorry about my noise that I make, the coughing. Sorry about that, guys. It's clearing out, guys. All right, guys, have a good day. I hope this is helpful. Please take care. Do not work with really high voltage. Make sure that you don't touch any surface area, the metal area of these tabs. Be careful. Always use a light bulb for testing, a 60 watt or maybe 50-watt light bulb to test out the first prototype. Please be careful with this. All right, guys, have a good day. I hope this helpful. All right, good day.